Right, this lesson, finally, you can get a break from the integration skills that you've learned that you should be very, very, very confident with. Well, if you're not confident with, well, go back to the videos and watch them again 10 times. But today what we're learning is when it comes to integration, the point of integration in graphically is about measuring the area underneath the curve between the x-axis and the area under the curve. However, no, you've done a lot of integration expression, how to integrate a lot of expressions, you realize some of them are not easy to integrate. So for example, if you're struggling with what I'm saying about, imagine this, okay, you've got three, you can just possibly have a go at these ones, see, you notice the difference, how to integrate each of them. Maybe cos cube x, you know, I'm not going to go through how to integrate them because you've done similar things before, but, you know, as much as they look similar, they're, when it comes to integration, there's a completely different league how to integrate them. So, right. So therefore, we must have a solution how to estimate the area. Well, there's it, trapezium rule. Trapezium rule at the end of the day is just a formula, which I'm going to go through later. So for now, let's understand the theory behind the formula, how the formula is derived. So first of all, we know the trapezium, or we work out the area, we can, under the curve, you've sort of done this in GCSE, which is we sort of divide them into strips of trapezium, equal width strips of trapezium. So they're equal in width, okay, in length. So the height is all the same. Now imagine we have to, let's call this x coordinate A, and this y coordinate, and this x coordinate is B. Okay, so we're integrating from A to B, and then we call this, okay, this point y0. So the y coordinate of that point is y0. That coordinate is y1. If you can't see clearly, it's y1. This is y2, and that's y3. Okay. Now, if I want to work on the area, I'm estimating in here, then the area will be estimated because you can see it's a curve in here. It's not actually a trapezium, but assume it's a trapezium, so it'll be half. Trapezium is a plus b times height divided by 2. The a and b are the parallel lengths, width lengths, yep. So that's your a, which is y0, and then plus b plus y1 times the height divided by 2, so half the same thing. That's strip number 1. What about strip number 2? It'll be half times a plus b, y1 plus y2 times height, and plus y3, which is not y3. So strip number 3 will be y2 plus y3 times height. Then, if we look at the algebra, we can see each term has a half and h, half and h, half and h. So why don't we try factorize it out? So half and h. Now, one question you might be thinking, why do I put equal in here, not roughly equal anymore? Because the roughly equal is there in the beginning. So we're saying the area roughly equals to this formula, this equation, the expression. But this expression actually equals to the next part, because what we write next actually equals to the previous part, not roughly equal to the area. So the half h equals half h times a factor of half h. Then the first term I'm just left with y0 plus y1. Second term y1 plus y2. Third term y2 plus y3. Then what you see is, apart from the first and the second and last term, there are double of each term in the middle. So we can rewrite as a half h times y0 plus 2 times y1 plus y2, because there are 2 lots of each in the middle. So 2 lots of y1 plus y2 plus y3. And that's actually the theory behind trapezium rule. Now imagine I'm going to split this area into more strips, okay, into more strips. Let's say I want to split into, you know, more strips. Let's say I'm going to split into, let me try split these into more strips, into 2 more, okay? Each strip split in 2 more. That means I've got strip 1, 2, 3, 4, 5, 6. So that means if I have 6 strips, and by the way, they look like a door. Does it not look like a door? No, anyway. So what can we do? Well, imagine we've got we're split into 6 strips. So how would these the first step change? Well, the first step will change it. We've got more terms, haven't we? We've got a half h this time y3 plus y4 plus a half h y4 plus y5, and then plus a half h y5 plus y6. Now, how does that change on the following step after? Well, if we change the step after, then we've got double of most y1, y2, and y3, and y4, y5 as well, because you can see they're a double of each. So all the middle terms, apart from y0 and the last term, y0 and y6 in this case, the rest of them will be doubled. So there will be more in here. So that is exactly the formula for trapezium rule. There's also the formula booklet as well. So you want to write down the trapezium rule. Trapezium rule. So the area equals the integral of a to b y of dx normally. Now it's roughly equals to h over 2 half times height times y0, the first term of y, plus 2 times y1 plus dot 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 up to that second last term, so it'll be n minus 1 plus the last term, the nth term, yn. That's y0, by the way. So that's the trapezium rule. That's trapezium rule. So what's h then? H essentially is, okay, if you look at the height from previous step, h essentially, if that's a and b, if we broke into 3 strips, then the height will essentially be b minus a divided by 3, because the difference from a to b, and then we divide with 3 strips, it'll be 3. So it depends on the strips you are dividing into. So height equals b minus a over n, where n equals number of strips. All right. So next, now we need to use a calculator for this, because we can use a calculator, the table function in the calculator. I'll show you later to do it. So next, first example, trapezium rule. Okay, diagram shows a sketch of the y equals sec x. The finite region R is bounded by the curve, the x-axis, and the y-axis, and the line x equals pi over 3. Was this the first? Hang on. Yeah, sorry, I was reading the wrong example. I was thinking why it's follow my notes. Anyway, so that's the second example. The first example is right here. Use trapezium rule to approximate the area bounded by the curve between x equals 1, x equals 3, and the curve y equals x squared using 4 strips. So using 4 strips, first of all, we're going to set the table values. Okay, several table values. So we've got x and y. So we've got 1 in here. Next, we can use a calculator to help us work out the values in between several table values. You can do it on your own. Now, y equals x squared is a nice one to do, but we can run a calculator. I want to show you how to use a calculator. First of all, I'm showing you both using the class width and the CG50. So for the class width, if you go to menu, this where's table. Yep, number 9. You see it, table. Okay, and then if you go on CG50, table number 7. On there. And then what you need to do in here is in CG50 type in x squared. So you use x in here. So that's x squared. And then for the class width, again, same thing, is x, but your x is the alpha. Close bracket, x squared, and then equal. And then for class width, ignore that because we only got one equation equal. For the class width, so for CG50, you press equal, then you have to press set. Okay, then once you press set, you have the same settings as the class width. Now we start from 1. If we go back to the question again, the question was from 1 to 3. So you start from 1, end will be 3. You press equal each time we want to go to the next step. Now, what's the step? Step is the height. We have the height as being, what's the height again? So the height is b minus a over 3. So the height is b minus a over n. B is 3, A is 1 over n, which is 4. So that's, you can work out which will be 0.5, or you can let the calculator do the work for you, actually. You can actually do bracket 3 minus 1 divided by 4. And here I'll do 3 minus 1 divided by 4 and press equal. The calculator will do the work for you. And then press equal again. Now on the class width, you can see the table values came out, whereas in the CG50 it doesn't. You have to press the table, this F6, okay, table, and you see the same numbers in here. This essentially is the first column is your X row, and the second column is your Y row. So you can copy them down: 1, 2.25, 4, 6.25, and then there are more, I think. Yep, up to 9. Okay, so I'm going to copy a table and draw in there. Usually, the exam will have given you the table to fill it in, or sometimes the exam will give you most of the numbers and ask you work out filling the gaps. So 1 here, 1.5, 2, 2.5, and 3. So 1, 2.25, 4, 6.25, and then 9. So again, question is, sir, there are 4 strips. How are there 5 columns? Because between each column is 1 strip. So that's strip number 1, another strip, another strip, another strip. So there are 4 strips. So each 2 columns together is 1 strip. Next, we're going to use the formula. So next step, we're going to use the formula. So how to use the formula? Let me copy and paste this from the previous. So here's the formula. Okay, just copy and paste from the previous slide. You don't have to write that. You don't have to rewrite the formula. You just have to apply the formula. This given the formula booklet. So the area. So we want to estimate the area. So the area equals to h over 2. We know the height is now 0.5. So we can write 0.5. Don't forget divide by 2. Okay, because a lot of students will say half. Okay, h is a half. Then they forgot the half. They have divided by 2 as well as part of the area of trapezium. So 0.5 divided by 2 bracket. So y0 is the first term in y. So that's your y0 in here. Okay, that's your y1, y2, y3, and y4. So what we do here is we take the first number y0, which is 1, plus 2 lots of anything in between apart from the n values. So that's y1, y2, and y3. So we'll put 2 times 2.25 plus 4 plus 6.25. Make sure I got it correct. Yep. And then close bracket. And then with plus a yn, which is the last value, plus 9. Shouldn't be too difficult to grasp. Then what you do essentially is just put a calculator and let the calculator work for you. And you get 8.75. If I have to be very technically correct, it should be roughly equal and 0.875. Okay, so 8.75 is the answer. Okay, right, next one. Yep, okay, so that's the one. Example, this time is y equals sec x. So between line 0 to power of 3, part A, create a table values of y correspondingly, giving your answers to 3 decimal places. So we need a height. First of all, we need a height. So the height equals b minus a over n. B is pi over 3, a is 0. And how many strips did they say? I didn't say, typo, my mistake. There should be 1, 2, 3, 4. Sorry, should be 4 strips. Can I ask you into 4 strips? Okay, just say 4 strips. The question will always give you this number of strips. My bad, I didn't give you the number of strips. My bad. There should be 4 strips. Okay, 4 strips. So we're going to make a table again. So n is 4. Okay, so pi over 3 divided by 4 is pi over 12. So we're going to create a table from part A, from this time from x and y, from 0 all the way to 4. Again, use a calculator. How do we do that? Right, so let's try that again. So let me press AC again. So let me clear that. So delete. So this one, sec x, there's no sec x in the calculator. So what we can do is we're going to do 1 over cos. So it'll be 1 over cos. Actually, one thing, make sure calculate in radians. So radians, let me change that. Shift, I think, menu. Yep. Okay. What is that? Degree in radians. Okay. Right. So then we can put on the left hand side 1 over cos x. So 1 over cos x. And then this one is 1 over cos x equal. And then set. Start from 1. Start from 0. I end with pi over 3. So you can put pi over 3 there. So pi over 3. So pi divided by 3. Left hand side. So again, 0. And then pi divided by 3. Step. We are doing pi over 12 as a height. So that's a height. So pi divided by 12. This is pi. Oops. Pi divided by 12. Equal. And then table. Now, one thing it doesn't give you is the x value is not a nice number. So, but we can take the y values. The question wants 3 decimal places. So we're going to write these numbers. So I'm going to show you how. Right. So we know it's going up by pi over 12. That means x, that will be pi over 12. So each time you're adding pi over 12, the next one will be pi over 6. If you do pi over 12 plus pi over 12, that's pi over 6 plus pi over 12 again, pi over 4 plus pi over 12 again, you get pi over 3. Okay, and then you put in the value. So when x is 0, y is 1. When x is 0, the question wants, now you have to be very, very specific. Follow the question. They want 3 decimal places. Do not write more, do not write less. Okay, so 1.035, 1.155, okay, 1.414, and then make sure you're rounding as well as you go. So 2, right? And that's it. That's the table. Part B. Use trapezium rule. You love to see that word trapezium rule because every time you see the word trapezium rule, you know it's an easy question coming to you. So that will be the dream for all the questions. Imagine 10, 12, 15 questions about trapezium rule. Yeah, that doesn't exist. Part B. So you want to use trapezium rule. So let's do that. Trapezium rule is when we use the formula again. So let's use trapezium rule. Part B. Okay. Trapezium rule. I want to make it smaller. Can I make it smaller? Yes, I can. Part B, trapezium rule. So area equals 2, or roughly equals 2 technically. H is pi over 12, so pi over 12 divided by 2 times, so y0, that's your y0, y1, y2, y3, y4. So you take the first number, 1, plus 2 lots of everything in the middle, just like the fillings in a burger, 1.035, you will double everything up, 1.155, plus 1.414. Okay, so after you double your ingredients, then you will fill it with the buns on the top, which is the last one, 2. Okay. Oh, it's like a burger. Yes, it's like a burger. So you got the buns in here, and then you got the fillings, tomatoes, sausage, egg, and then double it. Lovely. Okay. Right. Anyway, so put a calculator. Just plug in the calculator. You should get 1.34 in 2 decimal place. That's what I've got at 1.34. That's the answer. Okay. Part C. Explain with a reason whether you estimate in part B will be an underestimate or overestimate. This actually has been done in GCSE, but we're going to provide a technical reason for that. Now, how do we know it's an underestimate or overestimate? Well, if we try to divide this into 4 strips of trapezium, 1, 2, 3, 4. Okay. Now, trapezium means we'll join these 2 together. Okay. Now, can you see when I draw this trapezium, there is a little white gap between my straight line and the curve. And therefore, the area that we find is actually covering everything inside what we draw under the black line. So in other words, the area that we found is the overestimate because the actual area is actually less than the trapezium that we draw. Okay, so part C, it'll be an overestimate because you can't say because there's a white gap. The answer is you have to use knowledge from chapter 9.10 and 9.9, which is this curve is a concave or convex. You know which one is it? This is convex. Convex. Well, how do we know it's convex? So this, so we say first of all, it's an overestimate. Okay, because this curve is convex. So how do you, okay, so side note, how do you remember convex, concave again? So this concave, this convex. Well, remember, if you want to make it, if concave, like a cave, negative people live in cave, you see, you can make this cave, finish off, looks like cave. Okay, then we can set some fire in here. And that's the lonely person in here, sitting next to the fire, yeah, thinking about the purpose of life. On the other hand, in here, you've got people there's a convex, like a exponential graph. Okay, so that's how you remember. So that's concave, and that's convex. Right, so it's overestimate because the curve is convex. We can see it's going up like this. That's why it's a convex. So therefore, overestimate. And the reason is it's a convex graph. There's a very specific time you have to say it's a convex and concave curve. You can't say because your straight line, there's a white gap in between. Again, you can't say that. Part D. I spoke too early in the beginning lesson. We actually have to do integration in here. Part D. Use integration to find the actual area in exact value. So when we have to use integration. So part C. Is it part C? Part D. So the area equals, we want to integrate from 0 to pi over 3 of the curve of sec x dx. Okay, so luckily sec x, how to integrate this? I'll let you pause the video, think about this. When you're ready, you can play. To integrate sec x, we can use a formula booklet. The formula booklet actually give you ln, that's a modular sign, sec x plus 10x. Now keep the modular sign because you never know if that gives you a negative value or not. Oops, actually it shouldn't be that. It should be, because we've integrated, sorry, so it should be a square bracket, normal integral sign. I think that's the best thing that happens to you in 2024 or 2025, whichever year you're in. So yeah, get rid of the integral sign is the best thing happen so far. Next, then we can sub it in. So when you sub in exact value, you have to be extremely careful what you sub it in. So let me sub in pi over 3 first. So it'll be ln sec pi over 3 plus 10 pi over 3 minus, let me sub in 0 as well, ln sec 0 plus 10 0. Make sure you put in calculator one by one. Then you should get the first one. If I do ln with the modular sign, you should get ln 2 plus root 3 for the first one, and then minus. Now when we put ln, the calculator won't give you exact value. So the exam tip in here is do not put, if they ask you for exact value, do not never put in the calculator for ln, because whatever you ln with, it most likely not going to be a nice number. The next one is ln 1, which is 0. So that one is nice. So ln 2 plus root 3 minus ln 1 is just ln 2 plus root 3 in a bracket. Sorted. Nice. Part E. Find a percentage error. Percentage error, they're working out, means the difference between, is the percentage between the estimation and the real one. So question E, percentage error equals to that is the actual difference over, or if you want to put is the estimated minus original over original times 100. Okay, so essentially it's the difference. They're working out the percentage difference. So the estimated we've got is 1.34 from part B. So 1.34 minus original, which is ln 2 plus root 3 over the original, ln 2 plus root 3 times 100. Exam tip for you. You do want to put in extra ln 2 plus root 3 in the calculator. If you put ln 2 plus root 3 in a bracket, 2 plus root 3, where's square root? There we go, square root 3. Now you can see it's 1.31695, which is not far off from 1.34. That's a hint for you to know your answer might potentially be correct, your 1.34, because what you estimate should be too far off from the original. Okay, right. Then, so you put the whole thing in your calculator, times by 100, you should get 1.75%. I would suggest you put in a calculator, see if you get this. Now, sometimes when you see such a small number, you start to doubt yourself. Are you on the right track? Yes. I mean, in maths, unlike GCSE, when you see some weird numbers, there's no right or wrong. You can't really tell from it. So just go with your gut feeling, and yeah, 1.75%. Right? It's a positive number because the estimated value is bigger than the original. Next, finally, yeah, exam practice. Okay, so as said, this time it's just you don't have to use table value. You don't have to use table function. You just have to put it in. Most likely, the exam question give you a whole table and ask you to fill in the gaps. So pause the video, have a go at question in part A and part B. When you're ready for the answer, you can press play. Well, here's the answer for part A. You substitute 1.3, so you just put 1.3 over square root of the over square root 1 plus 1.3. Then you should get 0.8571. The question, once you give it 4 decimal places, again, do not put more or less decimal places than the question suggested. So 0.8571. Next one, part B, use trapezium rule. Love it when you see the word trapezium rule. No, then you use the final value of H. This time it's in 5 strips. They do not tell you how many strips. However, you can tell from there, there's 6 columns, 1, 2, 3, 4, 5, 6. Or think about this, strip 1, strip 2, 3, 4, 5 strips. the question did not tell you, so you have to work out yourself. So divide by 5, you got H 0.1. Now, probably there are 4 marks. It looks, quite silly for 4 marks for such an easy calculation. So yes, you're right. The calculation is not difficult. However, students often miss the mark by not showing the working out. So you must write this one out. Okay, 0.1 divided by 2. There was 1 year when I marked the question. They need to show everything correct in here to give the 1 mark, 2 marks. So it's quite stingy in that sense. Yeah, including the square bracket and the close bracket. Yeah. So you must follow. So 0.071, the first number, plus 2 times all the ingredients in the middle, plus, and then close it off the buns at the back, 0.9487. Another silly mistake students often make is they copy the wrong number. Yeah, it's quite often. It happens very, very often. They just copy, let's say 0.70071. They just copy the wrong number, say 0.6071, for example. Instead of 7, they put a 6 in there. It happens quite often. So make sure you double check your answer. Do it twice. These 4 marks, you don't want to miss it. Such an easy mark. It will be so silly if you lose these marks. Okay, right. And then next one, I think there's one more. Okay, for you to do. Pause the video. Have a go at the question. Okay. When you're ready for the answer in part A, then you can. Or actually, part A and part B. Okay, part A and part B. When you're ready for the answer in part A, part B, then you can play the video. Right, part A, again, easy question, 3 marks. You should get 11.25. I've shown all I'm working out in here. If you got wrong, check the number 1 by 1 and put it in calculate again. There might be, you might get a fat finger like I do. I always make something like this, so I do it twice. Fat finger probably come from the burger I just mentioned. Part B, and then explain trapezium rule, how you can make it more accurate approximation. I did not mention this, but you can, if you increase the number of strips, then it becomes more accurate. Well, why? Now think about the original we're talking about in here. What was it? Hang on, this one. Remember, when I split into more, then the area, this becomes more and more of a straight line, because right now it's a curve. Now you can see there's a curve. But if I split into more trapezium, more and more strips, then each curve in the trapezium becomes more like a straight line. Imagine we zoom in a bit more and more and more, then each strip, that line becomes more of a straight line. So therefore, the more number of strips that you create, the more accurate it will be, okay, compared to the real answer. So yeah, increased number of strips is the number 1 answer to go to for this type of question. Part C, use a calculus to showing each step. Now this is using calculus means differentiation or integration. Well, clearly, if we want to find an integration, if we want to find an area, I give it out. I will say this. I always do this. When I ask a question, I give out the answer when I ask a question. Use calculus, differentiation, integration. When it comes to area, it's all about integration. So what I want you to do is basically integrate it, okay, using the skills you've learned from previous chapter and find the exact value. So pause the video, have a go at the question. When you're ready for the answer, you can press play. Here's the final answer. Area equals 1/4 e to the power 4 minus 5/4. Okay, if you got it right, well done. That's the end of lesson for you. If you don't, let's go through why. Well, to integrate this, let's go through it step by step. So, okay, part C. The area equals the integral from 0 to 2 of the y, which is the equation 2 minus x e to the power 2x dx. Remember, I said about RTSP. Now, clearly, we can't use the formula booklet for this because formula booklet doesn't tell us anything about e. It only tells us something to do with the trig. So, trigonometry. So, RTSP. Now, first of all, reverse chain rule. First thing you consider is reverse chain rule. Does it work? Well, maybe not. But if you have to let y, what would you let y to be? Now, I'm assuming I would try reverse chain rule exam. Let's try. Okay, e to the power 2x. Shall I let y equals e to the power 2x? Let me try that. So dy by dx. Okay, that's 2e to the power 2x. Now, this is matching, but there's no 2 minus x in the front. There's no minus x in the front. So we know reverse chain rule. This doesn't work. Next, trig. Well, clearly not. There's no trig in there. S, substitution. They do not give you a substitution. Maybe you can, but I think the more obvious way is to use by parts, because when you see a product, you use by parts. So remember the formula, the by parts formula is given to you in the formula booklet. So by parts. When it comes to by parts, isolate rule. okay, or late rule, to be honest, because you're not in the pure maths, you're not doing any inverse trick. Unless you're doing further maths, then you might be useful. But otherwise, it'll be late rule for normal math students, normal maths. Late rule. Logarithms, not quite. Algebra, yes, 2 minus x algebra. And then e to the power of 2x is exponential. So we're going to let u to be the algebra. So we're going to let u, so u equals 2 minus x. And then the dv by dx equals to the e to the power of 2x. We differentiate, we find a counterpart for each of them. We differentiate this, it's minus 1. We integrate dv by dx, we integrate, that means the power e to the power of 2x, integrate 2x is 2, so a half e to the power of 2x. Remember, we divide by the power of x in here, the power of e, divided by power of e. Then we use the by parts formula, which is, so the area equals to, if I remember correctly, it will be uv minus integral v du by dx. Again, this is given in the formula booklet. So uv, so make sure you pick the right thing. Okay, uv, u is 2 minus x, u is, anyway, not English, v is half 2 minus x equals half e to the power of 2x minus the integral of v. What's v? V is e to the power of 2x. What's dv by dx? Oh, it's just minus 1. Nice. Dx. And then we also have to put the here be 0 to 2. Okay. Can we do anything with the first term? We can't probably do anything, so I'll probably just rewrite it without doing anything at all. Minus, this one simplified to minus e to the power of 2x. So the minus becomes, with the front becomes a plus integral of e to the power of 2x dx. Now this step is really redundant, not really necessary. Integrate e to the power of 2x is just plus a half e to the power of 2x again. So the integration is not too bad in this one. Thankfully, yes, there's nothing more heartwarming than seeing an integration that you can do in Excel. Trust me. Number one mistake student, or number one enemy when students see a paper is integration. The first thing they flip the paper is, let's see if I integrate this, if I can integrate this. There's nothing more confidence boosting by seeing it, especially you can integrate. In here, yes, then the rest of them you can sort of, yes, let's just sub in the numbers. You know, it's a chip off the shoulder. So times, so substitute 2 in the front. So 2 minus 2, and then 2 minus 2, and then a half e to the power of 0 plus a half e to the power of 2 times 2 is 4. Sub in 0. 2 minus 0, and then a half e to the power of 2 times 0 is 0, plus a half e to the power of 2 times 0 is 0. Now, don't think e to the power of 0 is 0. It's not. E to the power of 0 is 1. So just be mindful of that. But 2 minus 2 is 0. That's the whole gone. So it's just half e to the power of 4 minus, this one is 2 times a half, which is 1. So that's e to the power of 0, which is 1, actually, which is 1. E to the power of 0 is 1. So that's 2 times a half times 1, which is, you know, that's 1. Half times e to the power of 0, that's a half. Okay. Right, so 1 minute. Have I made a mistake somewhere? I feel like I might. Oh, I forgot the half. Sorry, I was checking why is my answer incorrect. Sorry, my bad. V is a half. Sorry, I should have put a half in there. I'm gonna write in green because I forgot about this. So let me. Yeah, so that's no, there's nothing wrong. So half. No, there's something wrong, but half. So that half times half, that'll be a quarter. My bad. So that will be a quarter. A quarter. No, not that. Not that one. That's a quarter. Yep. But it's not going to stop us from working to us around. So that's a quarter. So minus half. So, yep. Plus a quarter. There we go. So a quarter e to the power of 4. 1 plus 1 4 is 1/5. So minus power of 4. 1/4. Yep. And that's the right answer. You know, we got there, even though we make silly mistakes. So even I make silly mistakes, so it's quite common. So make sure you double check your answer as you go along. Right, and that's the end of the lesson.